Welcome back to Data Science for Humans. This is Elias Perunin, and this is part 4, where we're going to start to try and combine data frames together. Now, this is a multi-part series for combining data frames because we'll be looking at a few more complicated techniques. Nothing we can't handle, though. In our last tutorial, we took a look at how we can use pandas to clean up an existing CSV file. Now, we're going to open up a second CSV file with the eventual goal that we'll combine the two so we can do some statistical analysis. Let's jump back into our code and review what we've done so far. So in our last tutorial, we read in our original CSV file, we cleaned up the columns, we converted the columns over to title case, we cleaned up our fiscal year by stripping off the first two and last two characters, and finally we instructed Python on how to convert our string values in our count column into numbers that we can now work with. So now let's make things a little bit more complicated and read in a second CSV file. Just for the time being, I'm going to comment out using the hashtag or number sign. I'm going to comment out my line 24 where I write this data frame, data2428, back out to my hard disk. So what we're going to do is read in a second CSV file into pandas. Now, what does this data file look like? Well, this data file is creatively named 2429.csv. And this data file, again, it's pulled from the Ontario Open Government Data Portal. It breaks down the youth justice offenses by severity and count in a particular region by fiscal year. So our goal with this file is to be able to combine these counts with our admission types and see, is there any correlation between, say, some of the more serious violent crimes and the number of admissions to the youth justice system. So how can we read in this data frame? Well, check this out. I'm going to create a new data frame called data2429 and set it equal to panda.readcsv, and I'll give it the file name. I'll give it the name of the file, 2429.csv. If I run this whole thing, notice in my variable explorer now, I have two data frames. Our original one, data2428, and our new one, data2429. Now check this out. We've already got something really interesting. First, we can see that our columns are quite long in name. But look at this ranking column. So because pandas right off the bat was able to convert this to a number, we're not storing any objects, we're not storing any strings, we've already got a numeric ranking. But notice our count column, there's no highlighting. This means that we've got some sort of problem somewhere in here. We're going to have to clean up this column. Now, first thing we'll want to do is clean up the column names. Why? Well, they're very long, and we don't want to have to type out fiscal year / exercise fin. I'm sorry, I can't pronounce French this morning. I've had too much coffee. So I won't try. My apologies to Quebec. But first thing we're going to do is rename those column headers. We're going to say data2429 dot columns equals our new array. We'll call our first column fiscal year, region. Now, what are the other columns that we have in here? We have our ranking, category, and count. And we'll just call these rank, category, count. So again, now you can already see in data2429, we've got a column that's much easier to work with. Now let's pause for a second because I glossed over a really important detail, and that is our combining of our data frames. I mentioned at the beginning of this video that we're going to eventually combine these two data frames together to run some statistical analysis. How can we do that? Well, let's take a look at these two files side by side for a second. So I pulled up 2429 on the left-hand side and 2428 on the right-hand side. And if we look, We can see that we can do this join eventually, and I'm giving away the technique that we're going to use by saying its name. But we're going to be able to combine these two files because we have enough properties in common. For instance, both files have fiscal year. They're in different formats, but as we've seen, we can clean that up. And both files have region. Again, slightly different formats, but we can clean them up. Which means that we'll be able to see, we'll actually be able to combine these files and get a row, for example, that has fiscal year 2005 for central region, for homicide and related, our total count being 23, and the number of community, open, secure, and open and secure admissions. So now that we've renamed our columns, and we're ready to start combining these two files. Well, actually, let's not jump over that. We'll get to that in a minute because we have this other issue to deal with, which is our count. How can we deal with this? Well, let's take a look. Let's try to convert the data 2429 count column over to numeric. Check this out, pd.toNumeric data 2429 count. If we try to run this, again, we get a big ugly error over here. Check out this error. Unable to parse string less than 5 at position 37. Let's look at our data frame again a little bit closer, and we'll jump to row 37. So if we go down here to row 37, look at this. We have a string value in here, less than 5. Pandas does not know how to deal with this less than 5. That's not a number as far as Pandas is concerned. And this brings up a very important point when it comes to your data cleanup. This is an example of a choice that you will need to make in some cases when you get data files that are protected by certain data privacy regulations. In order to avoid identifying a particular offender, some data sources will give you a flag or a special value in case there is not enough data or less than a certain threshold of data for a certain measurement. So for example, if there's less than 5 offenses in a particular category, this file will give us the value less than 5. Now think about that for a second. What this file is telling us is that we have less than 5 morals offenses. That means we have a value between 0 and 4. How should we interpret that? What should we do? Do we interpret that as 0? Do we exclude it from our measurement? Do we go halfway and say, well, we'll say less than 5 is equal to 2.5? That's a type of judgment call you will need to make. But keep in mind, it may affect the final results of your analysis. Now, given that we have a lot of results here that are in the thousands, less than 5, converting that to 0, will probably not have much of an impact on your statistical analysis. But this is an example of a judgment call you will need to make. And it's an important point I like to emphasize whenever I'm instructing a group of new data scientists. The computer is not a replacement for your judgment. Because computers are great for running your prototypes, they're great for running your statistical analysis, and they're great for performing big, complicated calculations and repeated tasks. What they are not great at is reason, inference, and creative ideas. You have to instruct the computer exactly on what to do with a given piece of data. You and I, as humans, we can eyeball a piece of data and say, that looks high or that looks low. A computer has no context about that. It's going to do whatever you instruct it to. In other words, you can answer the following questions. Does your source data represent the truth? Does this data look reliable and clean? Are the real-world definitions the same across systems? And if they're not, you can make the judgment call to try and normalize those. Notice how we did that with our fiscal year column. You can figure out what bad data looks like so that you can instruct the computer on how to clean up that data. And then finally, you have to make those judgment calls on how to interpret missing or flagged data. Now, last time we ran toNumeric, we used string replace to clean up our column and then ran toNumeric. But this time we're going to do something a little different. We're going to instruct pandas that if it runs into an error of some sort, coerce the value into not a number. Why are we going to do that? Because in any statistical analysis, the special value not a number, or NaN, will be interpreted as a 0. In this case, we're going to make the judgment call that says less than 5 is small enough that it is probably insignificant, so we can interpret it as 0. So let's try running this now. Notice we have no errors. If we open up our data frame, we'll jump back to position or row 37. Notice again our count column is now nicely highlighted. Notice how we've got NaN, not a number. Again, row 37, not a number. So when we do our statistical analysis, this will be interpreted as a 0. Now we could go the full Monty and say, okay, instead of not a number, we could say that data 2429 count is equal to data 2429 count.str.replace, and we'll replace the less than 5 with a 0. And if we run this and take a look at our data frame again, and we jump back down to say row 37 where we saw those issues, again we see now we have 0. Now keep in mind there is an important distinction between not a number and 0. So 0 is, well, it's 0. It really does mean, or it should mean, that there are 0 measurements of that type. But what is not a number? Not a number could mean that there is a value that is simply unknown. And that's a very important distinction. Keep in mind that most human beings are going to interpret the value 0 as just that, nothing. Not a number is a way to flag that you may have missing values, that we don't know what the value of that measurement is. That could make the difference when you are running a statistical analysis and somebody asks for your data. There may be reasons why you want to actually keep the not a number representation. Now, what you might be asking right now is, what does that look like if we say, okay, what does not a number look like when it's saved out to disk? So we're going to say data 2429.toCSV. We're going to write this out to disk, 2429 cleaned.csv. We'll run this. Let's look at our data file that's been cleaned up. All right, I've opened up data 2429 cleaned. Now, we haven't cleaned up any of the other columns yet, but notice I've jumped here to line 37. Notice this is the line that's been giving us so much grief. This is the one that had the less than 5. Notice when it's not a number, we just get a blank value. So that's important. If we had turned less than 5 into 0, we would see 0 here. But because we said coerce anything that is not a number to not a number, we get a blank value when this file is written out. Again, this is a judgment call you need to make. If preserving the validity of that data is the most important thing, changing less than 5 to 0 may not be an accurate representation of reality, especially once that magnitude starts getting larger. Less than 5 probably isn't going to, interpreting that as 0 probably won't make much of a difference in your analysis, or if somebody else takes your files and does an analysis in the future. But what about if you turn that into, or if we talk about a case where we use less than 500 as a placeholder, or less than 5,000? As the magnitude starts going up, turning that into 0 could be a gross inaccuracy. So this is an example of a judgment call you will need to make. Let's go back in here and finish our cleanup. So we converted our count column. The last two things we'll do is we're going to convert our category to title case. So that's data 2429 category.str.title. And then finally, we're going to strip out the last few characters from the fiscal year column. So data 2429 fiscal year .str 04, and this should give us exactly what we want. Let's look at our data frame just to confirm, and look at that. We have fiscal year, region, rank, category, count. Our data files are both cleaned up and ready to be combined. In our next video, we're going to combine these two data frames and write them out to a brand new CSV file. These will be ready for statistical analysis.